All right. It's 9:30, so time to get back to work, at least for me. Oh, by the way, I forgot to mention the wireless password. So it's IoT Word Today. Please promise not to check your phones. You know, I'm giving you the password, but that's for after my talk, okay? You have to stay attentive. All right. State of the Union. So obviously, it's a bit funny for me to give this talk since, you know, I've been around since February only. So I certainly wasn't there for everything that I will speak about, everything that happened in the last 12 months. But still, I mean, it's really impressive, as you will see, the progress we've made, and even more exciting, where we are headed as an open source IoT community. So the whole point of this talk is really to give you a taste of, well, why Eclipse IoT is the best place for you to be if you're thinking about doing IoT, okay? So I will be speaking about our member organizations, our projects, our various realizations, and obviously various industry trends. Because I suppose if you are attending this conference, this is because you believe in the potential of IoT, right? But, I mean, yes, saying that IoT has a lot of potential in the market is one thing, but you know, this is just an affirmation like that, doesn't have any hard data behind it. So I thought that I would start by putting, whoa, interesting. Try reloading, so we'll see that. All right, time for the backup plan. So you see, one of the important things in an IoT architecture is really to have resiliency, redundancy, being able to recover from failure. So that's what I'm doing. Right in front of you. All right. So, welcome again. All right. So, when we think about the opportunity that is IoT, I think that's an interesting statistic. The fact that experts estimate that by 2021, altogether, all of the various markets of IoT will be worth more than $500 billion. When we think about IT, generally speaking, right now, you don't see many markets where there is double-digit or triple-digit growth, right? PCs, smartphones, enterprise software, it's all in the single digits, if there's growth at all. Well, in the case of IoT, there's massive opportunity there. And yes, there's opportunity, but at the same time, there are concerns, there are issues, there are problems. And every year at the Eclipse Foundation, we do a survey of IoT developers. And before I get into what we did as a community, I wanted to highlight some of the specific trends that we've seen in our latest survey. First, when we look at the top concerns for IoT developers, security, as always, is at the top. But it's at the top, but it's less prominent than it was before. Still number one, but we have less people saying that this is top of mind for them, which shows that slowly we're getting to a point where, at last, people are doing the right thing and implementing serious security so they can focus after that on actual features. Connectivity, in second place, data collection and analytics in third place. What's interesting there is that connectivity is now number two. Why is that? Well, probably because there are so many options for you to pick from if you want to design an IoT architecture. Zigbee, LoRaWAN, whatever. I mean, lots of options, even plain Ethernet, plain Wi-Fi, Bluetooth. I mean, as an IoT developer, what do you pick? Well, at least at Eclipse IoT, we have options for all of that. And in fact, we address security, we address connectivity, data collection. We've got tools for that. But still, it's really, this really shows that the market is in flux. Things are heading in a slightly different direction, although security is still very much important. Now, if we look at a wider set of developer concerns, the interesting thing is that, yeah, you see the slight decrease in security, and all of those things, performance, privacy, integration with hardware, standards, ROI, all those things, generally speaking, we've got something in the Eclipse IoT Toolkit for that. For example, integration with hardware. I mean, the presentations we have on Intel EMRA and UPM is a good example of something that you can use to facilitate integration. And then on the connectivity side, well, we have plenty of stuff there, and the talk that we'll have this afternoon, for example, about the Sparkplug specification on the top of MQTT is a good example of where the market is headed. So whatever you look at, we've got something for it. Now, if we talk about the verticals, the industry focus areas that are really, really important for developers, well, traditionally, IoT platforms has been in our community the first one. Why? Because lots of our members are, well, IT companies building software like RowTech for their customers, delivering value in the market. But more and more, we see other things emerge. So we see more end-user organizations, so to speak, to become members of our community. And then for them, home automation, industrial automation, automotive education, building automation, we see the field of what we can do and the field of what interests our community really become wider and wider, which is nice because we have a talk, for example, with Voltron at the end of the day about, yeah, energy management in the case of a digital building. So we see we really have the chance to have a program here that I feel addresses, multiple facets of what is really relevant for IoT developers today. Now, thinking about constrained devices, right now, the top 3 CPU architectures that our survey identified were all ARM, and then there's a good sizable chunk of other things in that space. But the one thing there that's key, saying that it's ARM is not enough. I mean, you have 8-bit, 16-bit, 32-bit, with FPU, without FPU. There's so much hardware variety that you need tools in order to abstract that hardware if you want your application to be portable. And we have a talk on that later, so that's very good. Thinking about edge nodes, there's still a strong ARM presence, but Intel is really there strongly as well, more in the cases where you need real horsepower, and ARM will be typically there where power consumption is the main concern. Although, I mean, it's mix and match, right? But what this slide or this result from our survey tells us is that there's a lot of diversity. So you need a toolkit that will be cross-platform. You need a toolkit that will abstract the hardware. You need a toolkit that will enable you not to be tied to a specific supplier, but really be able to pick the right hardware for the right task. And that's really important in IoT because the right hardware will make the difference between a so-so solution and a great solution. Finally, top programming languages. And here it's interesting. I mean, C and C++ have been around for a very, very, very long time and are really the #1 choice for constrained devices. Although you will see some Node, you will see some Java, but yeah, I mean, the smaller your CPU is, the more likely it will be C. And then it's completely the opposite on gateways. So you see Java and Python, which are inherently cross-platform to hold the lead there, and it's only normal because there you have obviously more horsepower to play with. And obviously there are hardware or let's say hardware abstracting solutions because containers are a big thing, especially on the edge. So we have a talk on that right after me, saying how you can use Eclipse technologies to run or orchestrate containers at the edge. And then in the cloud, well, it's the usual suspects, nothing surprising there. Although I was surprised to see so many people still using PHP. Oh, come on, guys. Okay, well, no, please. That's my personal prejudice. If you like it, please be empowered to use it and laugh in my face because you are better developers than me. All right. Now, communication protocols. What our survey really, really shows is that it's about MQTT. And you will tell me, no, HTTP is there and it's #1. Yeah, but HTTP is there because of REST web services on the back end. Okay? You won't deploy something calling REST web services in the field. Okay? So if we talk about serious IoT protocols, MQTT is #1. And Not only number one because it is the right tool for the job, but at the Eclipse Foundation, we have momentum to add specifications on the top of it to make interoperability better. And we have a talk on that. So stay tuned. So that's right after lunch. Also, what was surprising to me at least was that MQTT was so strong at 42% and co-op significantly lower at 15%. I've used co-op in the past. It's nice. So anyway, that simply shows maybe that they are really, really, really strong, a really strong focus on reliability or deployment with unstable network connections and stuff like that, where obviously MQTT is a better fit, but still, I found it a bit surprising when I saw that, but well, let us know next year when we'll have our survey once again, what you think and what you're using. All right, so whatever we consider, okay, we have lots of those trends. We see a lot of those things that are used and needed by people. But if you are to do IoT seriously, you must do it in an open source way. And why I'm saying that? Well, there's a bunch of stuff on the slide, but really the argument boils down to this. The end users of your product, whether they are organizations or people at home, they want to know, what is this device doing? And then if you are an organization, you're deploying sensors all over your digital building. They are asking, will this device be secure 15 years from now? Will I have to reopen all the walls to replace them or patch them? Well, the thing is, if your software is not open source, it's much harder to guarantee that your solution will be secure for its own lifetime. And obviously, it's much easier to guarantee that I know what this device does when I have access to the source code. So more and more serious vendors, okay, are open sourcing things and doing the right thing there. If you are dealing with people that don't, well, maybe you should speak with other people, like the people in this room from our member organizations. All right, so all of this to say that Eclipse IoT, our community, is really the open source center of gravity for the Internet of Things. There are other organizations that do a great job in that space. Apache, Linux Foundation, I mean, we're not competing. We are working actively with them. And that's why we have this presentation from somebody from the Linux Foundation this afternoon, okay? So we're not competing because everything that strengthens open source is good for us as well. But when you consider overall what all of these various organizations do, Eclipse is uniquely positioned. Why? Because we put a premium on intellectual property management. Not all open source is the same. Okay, yes, you can go on GitHub and download something, but what guarantees you that this code will not violate patents or the rights of somebody somewhere that will at some point sue you and your customers? Well, the thing is, when you start an Eclipse project at the Eclipse Foundation, we check that with you. And I mean, Jeremy there from Voltron is right in the middle of the process of contributing his code. And there's pain there because we check every license for every dependency that you have. And we check to ensure that all the clauses are right. And then we ensure every time you have new dependencies and all of that. I mean, that's the same for you, Kilton, right? I mean, yes, it's painful. But that means that when you download an Eclipse IoT component, you have the guarantee that it's all right on the IP side. And that's really, really important. And that means that companies like RowTech then can build commercial products on the top of it, without being bothered by those questions, because the foundation with its strong development process ensures that everything is all right. So that's really, I think, our difference in the market, so to speak. And it really makes a difference. So if open source is essential to IoT, we think that we have the best approach to it, which is to be serious and rigorous about the development process. All right, so our community, if you are less familiar with it, what's inside? Well, 38 projects and counting, new ones are emerging all the time. More than 350 contributors, 43 member companies and counting once again. So I'm quite sure a few weeks from now this slide would be obsolete. And nearly 4 million lines of code, which is a meaningless metric by itself. It's still nice. I mean, it's a nice big number. What this means, if you think about it, is typically if you work with constrained devices, you don't have lots of storage, you don't have lots of memory, which means that the libraries you're working with are small. So 4 million lines of code in our toolkit, knowing that most of the stuff we work with is for very, very small devices, it's quite impressive. And it shows that we've got something real going on there. But now let's have a look at something a bit more serious. I mean, when I said that we have a comprehensive toolkit, I mean, it really is the case. Whatever protocol or standard you're thinking about, we've got something for that. Whether it is MQTT and obviously the Sparkplug specification, which is something you will learn about this afternoon, the COA protocol, DDS, OPC UA, whatever protocol or standard that's relevant in the market, we've got something for this. Now, I'm not saying this is all perfect and it will work all of the box all the time with each other. I wish it would. We are working on that. We are a community and there's still progress to be made. But still, I mean, whatever need you have, we probably have something for you. And if you don't know, okay, what I'm talking about here, those various acronyms on the slide, well, it just means that you need to have a chat with somebody from our members organization, or with myself, to figure out what you need actually. And later in this presentation, I will give you a taste of what the process is to really start building something with the Eclipse IoT Toolkit. All right. I think this slide better represents our growth in the last year. So since last year, okay, and there was roughly speaking at the same time last year an IoT Day, we had 9 new projects, and our existing projects put together 16 releases. Now, a release at the Eclipse Foundation is something serious, because as I said, we review each dependency, that kind of stuff, so that's not just, oh, let's put up a release and upgrade the version number. No, this is serious. So the fact that we've had 16 releases is significant, and not only that, I mean, those 9 new projects probably didn't have the time to release. They're just brand new. So this shows you what kind of momentum we have, and this nice little image that I put together put you the names of the projects that released in that space since then. So that's, yeah, I got fancy there. Anyway, all right. That's my feminine side, I guess. Okay, now, we've got some growth, but let's remind ourselves why we are here. What's the Eclipse Foundation is all about, and specifically what our IoT Working Group is all about. 3 important words: open source, standards, and collaborations. Yes, we have companies that are members that sometimes are competitors, not, well, and sometimes more than sometimes, but that's fine. Because essentially, no one organization, no one company can deliver everything you need in IoT. So you need to work with others. And that's why we put so much emphasis on collaboration and working in the open. This is really about building an ecosystem that's viable, and then companies can build commercial products on the top of it, but really the base is collaboration. And ensure that we can capitalize on this big IoT opportunity, because that's the thing. If we don't, put our act together, people will start losing trust. Already you see Google recently, they are all reorganized, everything in their Nest family of products. And then people are left with broken smart homes, without a path for upgrading or something. So we can't do that. As an industry, we cannot do that, okay? And our approach to counter that is really to work together to ensure that we do the right thing for ourselves and our customers and partners. Right, now, our working group, what's inside? Well, we've got 3 strategic members: Bosch, RowTech, thank you, RowTech, once again, and Red Hat. And then 41 other companies. Many of them are represented in the room today and are among our speakers. So where there's always space for more. So whether you are, you know, an OEM, a software shop, a hardware shop, whatever, there's place for you. And just to give you a taste of, yeah, okay, I'm anticipating a bit there. So anyway, whatever you are, there's a place for you. We'll show this very, very quickly. Now, one important thing, we published a brand new case study about how our strategic members are working together in order to deliver value in the Eclipse IoT ecosystem. So this shows how Red Hat, RowTech, and Clara have been working together. And it's really great because this shows that our approach works, essentially, in the sense that they are sometimes competitors, sometimes collaborators, but working together to build the IoT, and you can join that. You can join that. All doors are open. All right, so if we look at our ecosystem, there's lots of variety in there. So we've got OEMs like Bosch and Siemens that actually, and well, we could put RowTech in that category too in one way. Although I put them in the hardware manufacturers column, I mean, some of them have multifaceted businesses. But essentially, we've got OEMs, we've got traditional software vendors like Red Hat and Canonical and Contact. We've got hardware manufacturers and all sorts of hardware. I mean, RowTech is doing IoT gateways. Intel is doing mostly processors and boards and components, but then they have the NUCs, for example, the new units of computing that you can buy as well. So all of them have a different focus, but they all work together in this group. And then we also have some telcos, IT service companies, research institutes. Research is a big thing at the Eclipse Foundation. We have research projects. People don't know that. Our IoT Working Group is not driving directly those projects, but we have some IoT research projects. So if you know academics that are passionate about IoT, send them my way. I mean, they are more than welcome. And we've got quite a few members in that category as well. Now, this IoT Day is just one of the various initiatives that we have as a working group. We have a virtual IoT meetup that we run. Well, sometimes it's every 2 weeks, and sometimes it's every month, and depending on who we can cajole in presenting, because if it was me all the time, I mean, can you imagine that? Oh, gosh. And so we'll have one in June, for example, sharing and analyzing in deeper detail our results from our developer surveys that I will be running. Then there's the Open IoT Challenge, where Contact Software and Intel were the sponsors last time. So thank you for that. The challenge is really an opportunity for people to compete and come up with interesting ideas. We had to cancel the last one, partly because there was a transition in this position for program manager and for other reasons. But let's say that the next one will be awesome. So looking forward to a new, put together a new formula and put the fund back into this competition. And obviously, we've got our IoT marketplace and test beds. So test beds, right now, we have 2 of them. One is about asset tracking management, the other about production performance management. So please have a look. You will find those on our website. There's a page specifically on the website about those test beds and how you can try them out. It's really, each of those test beds is detailed, so you can see what's the architecture, what are the components, et cetera, et cetera. So it's really great. Now, I put there a quote among many, many authors that we have, just to show how important to our members, and especially our strategic members, the Eclipse Foundation and the IoT Working Group is. So, I mean, I won't read that aloud, but just to say, I have lots of great quotes from RowTech as well. So I will be presenting twice at their booth. So if you are interested on how specifically we work with RowTech, I'll be speaking twice at their booth this week, where you can see exactly how we help them and they help us building a strong IoT ecosystem. Now, I told you new projects. So what did we have actually as new projects since April 2018. And here is a selected list of them. They are not all of them are not there because some of them are so early in the process that it would have been a bit tricky to put them. But when you look at it, I'm not getting through the whole list, right? It's really for your reference. But when you look at it, it's really interesting to see how well they match the concerns of IoT developers. So for example, if we talk about standards, so we've got the first one, Keeple, about contactless payments using the Calypso standard, and Tahoe, which is our own implementation of the Sparkplug specification, okay, which defines a standard MQTT topic namespace, payloads, session state management on the top of standard MQTT. And this means that Tahoe can be used in various devices that you would be building and selling to ensure that they are interoperable. And we are always looking for new members in that space in the sense that right now we have some verticals represented, but we want to expand that. So, well, I'm anticipating a bit once again on the next. So I will say nothing else for now, but it's really, really important to see here the role that specifications will play in the future of the Eclipse IoT ecosystem. So we need not only people that are willing to write code, but people that will tell us, this is how my industry works, and this is what you need to deliver for me to deliver solutions in that space. Then integration with hardware, plenty of it. I mean, Keeple once again for touchless payments, but I mentioned it a few times, Intel's Emra here, which is a library with UPM that abstracts the hardware, the actuators, the sensors that you've got. Voltron about energy management, so you will integrate with HVAC systems, speaking BACnet and Modbus in order to drive, well, to get energy readings and that kind of stuff. And then Yasham, which is about integrating with consumer IoT devices. Talking about connectivity, Teo once again, and Yasham. So I could, go back to my slide at the very beginning and show you once again the top of mind for IoT developers. And just in our new projects, you see how well we cover them. And think about all the other projects that we have. So when I say we have a comprehensive ecosystem, that's really the case. Now, okay, I've been talking and talking about stuff, right? But how does this look day to day? I mean, if I'm new to IoT and I want to solve a business problem, okay, how do I use this toolkit to deliver something, anything? So let me give you a very simplistic example there. I'm not pretending this is the most fleshed out example in the world, but really I kept it simple so that we can all understand where this is going, all right? So the idea here, you are working for a company that makes machines, whatever they are, ice cream, maybe ice cream cone machines, whatever. And you have a good business going on. But you would like to introduce a new service so that you will bring additional value to your customers. Okay, so you want to install sensors on your machine so you can do preventive maintenance on them. Because right now, what your customers do, machine's broken. It's always broken at McDonald's. Machine's broken, customer calls, then they wait for a while, and their own customers are angry, and then somehow a technician will go and fix it. Would be better if we could, get in real time how well the machines are doing and plan the maintenance accordingly. And there are two main business drivers there. First, obviously, the customers and their customers will be happier. But there's also the dimension of making a better utilization of your field technicians. Why is that? Because some weeks they are overloaded, customers will wait for days and days before they can get their machine repaired. And other weeks, half of the team is at the office doing training or something. Not very good, right? You're not making proper utilization. And then it's more complicated to have the right size for that technician team because you don't know between the spikes and the downs, exactly how to plan. So the whole idea there is to put sensors on existing machines or to start building your machines with those sensors built-in going on, and then ensure that your customers are happier and that you can plan really maintenance in advance so they don't even have to phone you. They just show up, do the maintenance, repair, whatever, and then everybody's happy, all right? So how do I build this? Where do I get started? Okay, well, essentially, if we have a very, very, very high-level view of the architecture, there will be some kind of cloud application, right, that will help customers know that the state of their machines, for example, and when the, to specify maybe when the technician could actually come to the office and that kind of stuff. And then obviously part of the application would be also for the technicians to use, yada, yada. But we don't focus on that, okay? We know there will be some sort of cloud app. Could be a large SAP system or Oracle or whatever. Could be an in-house app. We don't care, but we know it's somewhere in the cloud. Okay, so our focus here is really about the constrained device, so our sensors and this little controller that will drive them, and then the edge application. Now you will tell me, edge application, why is that? What's that thing? Well, in this case, maybe I have hundreds or even thousands of those machines in my factory. If I stream real-time data from those sensors to the cloud all the time, 24/7. One, I'm wasting bandwidth. Two, maybe if we talk about an industry that's not ice cream cones or whatever, but something more serious, you could even endanger lives. Endanger lives? Yes? Think about it. Think about an oil and gas refinery. You need to close this valve at this precise moment, otherwise the whole thing blows up. Well, you don't have to go you don't have the time to go to the cloud and wait for a reply when the network is flaky and there's latency. You need to bring the decision closer to the data itself, which is why you need some kind of what we call an edge application, something that's, alongside with the machines, so to speak. So in this architecture, we have two main components. Our home little constrained device that will drive the sensors and gather the data and push that to an edge application that will analyze in real time the stuff. And maybe every 15 minutes, we'll just send a very quick message to the cloud saying, everything's fine, everything's fine. But then when something happens, we'll start streaming in real time with all the relevant data so that technicians could know what is happening at that specific point in time, okay? That's really the key difference there. So this means that at the hardware level, we need to figure out some kind of board and the actual sensors that we'll be using. So that's at the bottom. And then obviously pick edge nodes or gateways that will be a good fit for whatever use case we have. So I won't go deeper on that aspect of things, focusing on the software. But remember that everything I'm discussing there, there's a software component to it and obviously some hardware in the mix as well. All right. Now, the roles and characteristics of the various components that we've got, okay, you have really to keep that in mind when you're picking the components. So in the case of the constrained device, well, it's a constrained device, okay? You are working with a processor that will be maybe, 60 megahertz with 64K of RAM and maybe 500K of storage. I mean, would have been pretty powerful when I was 10 and starting with computers, right? But trying to do something today with that is quite impressive. Obviously, the emphasis is on low power because you don't want to have to replace those batteries every 2 months or even every 2 weeks. So you really, really, really need to factor that into the equation. And obviously, you're building something that's really specialized. Then, thinking about the edge application, the premium there is on connectivity, okay? It's really about, and we've seen how important connectivity is to IoT developers. This is why. Connectivity, messaging, so that's why you need protocols like CoAP and MQTT in there that are reliable and that will make sure that you are not missing on those messages that could save lives in some cases. And then obviously that's the whole concept of edge computing, right? The fact that you bring processing closer to the data. I'm simplifying a bit there, and I'm sure Kilton has a much better definition on that, but let's say we'll be content with that. And then on the cloud, on the other hand, it's all about scaling out, integration, data analytics, but we're not focusing on that right now. I put it, because I'm a sucker for filled slides with lots of nifty icons. Okay. So going deeper, what do we have to take into account when designing this constrained device? Well, at first, okay, the basic layer is to have some kind of OS or real-time operating system as the foundation. And you will say, oh, but I don't have to. I can write an app that will be self-contained. Yes, you can. But why do you have an operating system on your phone, on your computer? It's because it delivers services that are reusable and that it enables you to write your application to solve your business problems instead of solving technical problems. Plus, I don't know about you, but writing drivers, hardware support, I'm good, but I'm not that good, all right? So really, you need some kind of base layer, foundation layer. And then, obviously, an abstraction layer. Why? Well, I don't know about you, but if I'm building thousands of machines every week with a small microcontroller and sensors in it, the last thing I need is to be at the mercy of my sensor supplier or board supplier. Okay? So an abstraction layer means that your application is portable, so you can change, okay, the bill of materials at any time, okay, to suit whatever's cheaper, to suit whatever's available, to suit, a new hardware on the market that will be more power efficient, whatever. But you don't want to recode every time, so you need this abstraction layer. And then you pick a communication protocol, obviously, that will suit your use case. On the edge, well, once again, you need some kind of OS. And you need an application runtime. Could be anything. And in this case, with the emergence of containers, you can pick really anything. Although, please be mindful about memory usage, power consumption, once again, because obviously those gateways may be in situations where they will operate on battery or that kind of stuff. So you can use whatever you know already, but maybe you need to discover new tools and new ways of doing things, because this is not the same as building a bog standard web app, okay? And then obviously communication protocol support once again. And then in the cloud, the premium here is about connectivity. There is some kind of operating system or platform as a service, whatever, we don't care. But the one important thing here is message routing. You will tell, why do I need that? Message routing. Well, the thing is, if you're building a solution, okay, right now it integrates with one application in the cloud. And then other departments will get wind of it, and they will want in. So if you closely tie your IoT solution to the back end, you're done. You will be stuck. That's developer hell right away. Don't do that. Put some routing, and then you can send the messages everywhere that they are needed. This is about publish and subscribe. This is about there are many ways to implement that, right? But please think about this. This is a critical component. All right. So now we have an idea of the various things that we need. So what do we have in the Eclipse IoT Toolkit that can fulfill those roles? So let's have a look. Okay. So we don't have an operating system, as I said, so you can use FreeRTOS or Zephyr from the Linux Foundation or other solutions that suits you, okay? And we have a session this afternoon about picking the right OS or RTOS, so please be there. It will be interesting. But we have abstraction layers. So the brand new Intel Emra and UPM are an example, and we have a brand new project from Bosch in the same space, not necessarily doing the same thing, so you would have to study each and compare and pick whatever is right for you. This is another important characteristic of Eclipse IoT. We have different approaches to the problems, and we're not there to impose any specific vision. We are here, to work and collaborate on stuff that helps IoT, but there is overlap. There will be overlap, okay? And that's fine. Developers ultimately choose. You choose. I don't. But it's exciting to have all those nifty tools, to be sure. All right. Then, on the edge application side, so in this case, we'll be putting an MQTT broker on the edge. Why is that? Because if we have thousands of machines locally, we send that to the broker, and then whatever in the cloud will connect to that broker as well and just listen to whatever is relevant. This means that our constrained device will use Eclipse PAHO as the MQTT client, okay, to send stuff around. And then the Mosquito MQTT server could be in its own little container, and then you have your own little analytics application that will be in a separate container. And there are many ways you can bundle everything together, but then, anyway. I mean, that could be the topic for a whole day of presentations, right? So I'm not, but I'm simplifying things there. Assume there's this broker somewhere. And then in the cloud, PAHO, once again, to connect to the MQTT brokers that are in the field, in the various factories that we have at our customer sites. And then message routing through Eclipse Hono, which is a high-speed, high-reliability message routing solution. And some of our member companies have their own commercial products built around Ono or built on something else, but they have offerings in that space as well, okay? But that's one possible architecture only. I'm not saying this is, you know, the reference one or anything like that. We don't have reference architectures. We don't have even reference implementations, okay? We have rather implementations, and that's all. And the market, the developers choose. You choose. All right. So the one thing is that, you know, we could go on and pick components for other roles and stuff like that. But whatever you need, and, you know, this could be, you know, going through this graph and discuss all the options could be the topic for a whole day in itself. But we've got what we need. We've got what you need. All right. Okay, now the last stretch. Looking forward, edge is one particularly important concern right now in the market, and with good reason, because as I said, you don't want to stream real-time sensor data through the cloud. So one of the interesting things that we have going on is that the Eclipse Foundation, and well, this is not a formal announcement or anything like that, but we are working on a proposed new working group about edge technologies. Okay, and I'm quite sure you will learn a bit more about that in another presentation, but we'll have another working group parallel to this one. And I mean, once you are a member of one, you can be member of the others. Hey, no problem. It's all free anyway. Well, you need to be Eclipse Foundation members, which is not free, but anyway. And then we have also a proposed Sparkplug working group that eventually will be announced as well. So if you are in the building industry, if you are in the automotive industry, if you are in the industrial, you know, making machines like I just described, we need you. We need you to make specifications that make sense for your industry. And you have the advantage, this is brand new. Well, we haven't formally announced it yet, right? So this will be brand new in a way. You have the chance to be the first and shape your industry for years to come. So please join us. All right, so if there are only 4 things you should remember about this talk, about the fact that I do bad jokes. First, IoT is a real opportunity. It already drives real outcomes in the market, but even more so as we've seen going forward. It's really one of the last huge opportunities remaining in the IT market, okay? If you are to do IoT, you need to do it the open source way. Otherwise, people won't trust you, okay? I think that's really important. Then, if you are to do open source IoT, Eclipse IoT is the best place to be. I hope I convinced you of that. If not, well, we'll need to have a few drinks, I guess, and then, okay. And finally, our community is really growing. It's the right place to be, and others have made that decision, so hopefully, at some point, I hope that your organization will be a member as well. Now, my call to action, plenty of stuff. Please learn about our projects, ioteclipse.org/projects. And if, well, we are currently working on overhauling that page. I won't say it's the best thing in the world, but at least that's what we've got. If you get lost, you're not sure what to pick, reach out. Reach out to our members. Reach out to me. I mean, we have our mailing list. I'm on Twitter, whatever. You know, we can help you. We're there to help you pick the right solution for you. Try out the technology. It's all open source, okay? So please download the stuff and get started. Nothing is preventing you. And obviously, consider as well the various commercial products that our members are churning out, obviously. Subscribe to our newsletter and follow us on social media. And we'll have other IoT days and other events. So one IoT day will be in Paris, but none of you were in Europe, at least when I asked you first, so that's maybe less relevant. Although if you want me to hear a bit, speak a bit in French, well, that's Quebec French, anyway. You can go to Paris. Otherwise, we'll be in Germany for EclipseCon. And the nice thing about EclipseCon this year, previous years, we had only a single IoT day in a dark corner of the building. Nobody wanted to go there. Well, maybe nobody, almost nobody. This year, it's merged with the main conference. So, 3 days of IoT talks. It will be really exciting. The call for papers will open. So if you have interesting stuff that you've been working on, we are really looking forward to hear about it. And that's it. We're done. Not much time, I guess, for questions. Sorry about that. I'm always doing that, sorry. But we'll have plenty of time to chat. So thank you so much for your attention. Thank you so much for being there. And please stay for the whole day. We have quite the slate of speakers. Looking forward to chat with you and hear what they have to say as well. So thank you very much.